Hi everyone, this is Simple Tronics. Um, here is a demonstration of, although a work in progress, not completed yet, an Arduino based burglar alarm system for a small building. It's still a work in progress, but it currently has a lot of features going on here. So this is basically a burglar alarm system. It has 4 PIR sensors, 4 of these, and a magnetic rate switch for door opening and closing detection. This is not yet configured yet. So here is an high decibel buzzer. This thing is basically a buzzer that is very, very, very loud. This is a 4x4 keypad matrix and a 16x2 display. There's a switch here, and of course this device is to be stationed somewhere inside the building. Then these sensors are going to be at the 4 sides of the building: the front, the left, the right, and the back. So of course this wire can be extended. I just made it short for this demonstration purpose. Okay, so now, like I said, it has many features. It is designed to be armed at specific times of the day. So for example, of course this project was inspired by my friend. He owns a shop and he faced a lot of security challenges, so he wanted something that would notify him of security threatening activity whenever he's close at shop. So this device can be configured to be armed at specific times of the day. So for now it says status disarmed until 2030, that is around 8:30 p.m. so it could be, I can self-arm it now. It can be forced armed now. Okay, so I can choose to force arm it right now, even if it is not up to 8:30 p.m. yet. I've removed the sensors because if I arm it now, it might start making noise here. Okay, so see, arm now. Yes, alarm activated, so it is now armed. Now the time is now showing the time that it will be automatically disarmed, which is 9:30 in the morning. So this is basically designed for somebody that closes the shop around 8 in the night and opens the shop at 8 in the morning. So A is for next, because there are a lot of functions here. The next one here, we have on time. Now here is the on time, the time that it would arm, 20:30, and the off time is 9:30. We can actually change this time to whichever time we want. So I could decide to change it. I can say on time, change, set on time, set off time. So I want to change my on time, which is my arming time. I want to change it, so I'll click on 1. 2 is for off time, so 1. Now I want to change it to maybe around 5 p.m. in the evening, and 5 p.m. is equivalent to 18. Sorry. 5 p.m. is 17 in the 12-hour clock format. 17, let's say 17:30, and it's saved. Now we have 17:30. Off time, I want to change that to around let's see what. Okay, change off time, or I want to change that to, let's say, just 20, and that's saved. Okay, so the next, so I have PIR motion count. Now the algorithm designed for these sensors to work, because these sensors, they pick up movement, and of course we don't want this device to be triggered and start making noise when maybe somebody is just innocently passing beside the building and it starts making noise. So it is designed to track activities, persistent motion around 3, 4, 5 times before the buzzer start making sound, because around the building in the night the place is usually silent and nobody should actually be around. So in case somebody is around, the person should just, maybe if somebody is walking beside the building and this is just gonna peak maybe around 1 or 2 movement at most. But if the movement is getting to 3, 4, 5 and above, then the device will be triggered and the alarm will be activated. So the next, so magnetic door sensor. It says the door is open. Now this is a magnetic reed switch. It is designed to be installed with the door. So when the switch is opened, one side of this switch will be as one side of the door, and the other side will be at the other side of the door. So if this switch is separated, then a circuit will be opened and the device will know that the door is open, then the alarm will be activated. Then the next one, although I'm still planning on installing this one, I'll make a video of that later. The next thing, now this device has a real-time clock, so even if the device is shut down, the time will still be correct. It has a real-time clock and the time is always correct, and of course the time can be changed. You can change the time, set time and date. Yes, no, I don't want to do that now. So here I have an emergency number. Now this is the number that emergencies are being reported to in form of SMS and in form of a call, depending on the threat level. So this design is programmed to have 2 different threat levels. So when activity is picked up by any of these sensors, then we have a threat level 1. We just send an SMS to this number and this guy makes noise. But when the door is opened, that is a threat level number 2. Then an SMS and a call is sent to this number. A persistent panic call will be made consistently to this number so that the user will be easily aware of what is going on right there, right now, as at that moment. Then this will keep making continuous beeping sound. So that's for that. And this number can be changed. If I want to change it now, I can press C, change number. So I'll just type in a new number, let's say 08100901492. Once it's 11 digits, it's saved, and this number is saved in the microcontroller EEPROM. So the next, of course, so there are still more functions that are still coming here. Remote arming, remote disarming. The user can decide to remotely arm this device wherever he or she is by sending an SMS command. Then when the device receives the command, it automatically arms itself, and when the device is making noise, maybe upon false alarm or something, the person can remotely disable the alarm to shut down the buzzer and disarm the system, or probably press some bunch of button here to shut down the alarm. So more features are still coming to this thing. More features are still coming because I'm still waiting for my GSM module. The module I bought is not picking up network signal, so I had to make an order for another one, but it's not here yet. So once it comes in, I'll do a demonstration of that. Okay, so let us test this thing now. So we have motion count. Motion count is 0. It's 0 for the 4 sensors, and that's because I've detached the sensors because I don't want trouble. So let us test it now. So like I said, this is still a work in progress. For protection's sake, these sensors are going to be shielded and covered. All these areas will be covered, then only the wires will be appearing from the sensor, and the sensors are detachable from within via a screw terminal so that one could increase the length of the wires. Now the sensors are connected. Now we are picking up movement from this screen. Obviously this screen backlight shuts down around after 20 seconds to save power. So when I press any button, the light comes up back again. So now we are picking up motion. I want to stay still, and because it's picking up motion from my camera, and I want to stay still and let everything go back to 0. Okay, B is still at 4. Okay, A is now at 1. We want to gently go back to 0. The sensors are quite sensitive. So now I'm going to go and arm the system because it is currently disarmed. If I arm this system now and any of these sensors goes to level 2 or 3, the guys start making crazy sounds. So let's go and arm it now. I want us a moment, please. A moment, please. Please go to 0. Go to 0. Go to 0. Go to 0. Oh, come on. Oh, okay. I'll let up. I just hope it doesn't. Okay. Gently, gently, gently. Now. Yes. Now let's go back and see. Now let's. Okay, it's now shut up. Okay, so if I should move, A is now 2. If one. So we can see it only triggers when one of them is 3 or 4 or 5 or whatever number. Then we go back to 0. And if I should wave my hand again around any of them, we're coming up to 3. That is. So oh God, that was crazily loud. Okay, so that's a demonstration for now. When the device is complete, while making that sound, it's supposed to send a text message immediately to that number, and